The senior Kangaroo from 2019. Let's get straight into it. It's 1 hour long, by the way. All answers are 3-digit numbers, although the answer could be like 4 and you just write the answer as 004. It's not multiple choice, so it doesn't work in quite the same way as the regular senior challenge. It's a bit different, but let's get into it. So I looked at this for a while and thought, is there anything intelligent I can do? And then I thought, no, I'm just going to list out the factors and then I'm just going to add them up really carefully. And I genuinely still don't know what the point of this question is, other than to annoy you and make you do a ton of boring numeracy as the first question. I don't know whether there's a more intelligent way of doing it other than just listing them all out and adding. I don't know. Probably. I hope so, because otherwise this question is dumb. Question number 2. So 2 to the 4 is 16. That equals 4 squared, obviously, also 16. What about 2 to 16 and 16 to 2? Let's start with 16 to the 2. That can be written as 2 to the 4, as I just said, 2 to the 4 is 16 to the 2. Multiply those together to make 2 to the 8. Now, 2 to the 16 is 2 to the 8 times 2 to the 8, because you add the 8s together to get 16, which means this number is literally 2 to the 8 lots of this number. So it's 2 to the 8 times bigger, which is 256. If you know 2 to the 10 is 1024, you can divide it by 2 twice to quickly get this. Otherwise, whatever. Okay, so two diagonals of a quadrilateral are perpendicular, so if I put them down right now, I can say those are the diagonals. Length 14 going across and 30 going up. They're meet at right angles, and I can just fit the rest of the shape in around them, right? So there's the shape, and these are the diagonals of that shape. They're perpendicular. What's the area of this quadrilateral then? Well, if I draw a shape all the way around it, the area of this red shape is just its base, which I guess is 14, because it's there, times its height, which is 30. So the area of the red shape is 420. But if you notice, my quadrilateral takes up exactly half of this space, right? In each quadrant, it's taking up half of that quadrant, so I just divide that by 2, and I got my answer of 210. Good. Question number 4. So obviously I want to simplify all of this. And now how many ends do I have? Well, I've clearly got one here and then one for each of these 20 brackets. That's 21 ends. And what about all the other numbers? What do I get when I add those together? Well, hopefully if you're going into a senior math challenge, you know that the sum of the first n consecutive integers is n times n plus 1 over 2. This is essentially the triangle number formula. I'll link a video in the description below in case you don't know where this formula comes from. But you just have to use this for the first 20. So the first 20 is 20 times 20 plus 1 over 2, which is 210. So these all add up to 210. You put that in, you take it away, you divide by 21. Now to divide this by 21, what I would do, I don't like dividing by big numbers, so I find two smaller numbers that make 21, like 3 times 7, and I'll divide this by 3 first, and then I'll divide that by 7, and that will be this divided by 21. And now, of course, if n is bigger than that, n has to be bigger than 87, or 87 or bigger, so it's 087. But this trick of dividing by two things that make that going to be very useful when you don't have a calculator. Number 5, so these are regular pentagons. They have perimeter 65, so 65 divided by 5 is 13, so each of the sides of these pentagons is 13. I know that the interior angle of a pentagon is 108, and that's the kind of thing you just want to know, rather than having to spend 30 seconds working out. Just know it, save your time. That's 108, which means that's 108. 360 minus 2 of them makes that 144. And essentially, I just want to know what regular polygon has an interior angle of 144. And now it's much easier to work with exterior angles than interior. So 180 minus 144 is 36. So I know the exterior angle of this currently unknown polygon has exterior angle of 36. And 360 divided by 36 gives me the number of sides. That means the number of sides is 10. So this polygon has 10 sides in the middle here. Each one of them is 13 long. So 13 times 10 gives me a perimeter of 130. Okay, number 6. So as soon as you see this bad boy, you do this bad boy. You factorize as soon as you do. Just do it as soon as you see this at all times. So factorize this. This is 2019 equals this times that. Now I know 2019 could be written as 1 times 2019, but how else could it be written? Well, I don't know, so it's clearly not even, so it's not 2 times something. But get out some bus stops, and I found very quickly that it's divisible by 3. 3 times this. I couldn't find anything that I could bus stop with that to give me an integer, so I'm assuming that's probably prime, and I'll run with that idea, just because I can't bus stop it with anything and not give me a decimal. So I'm going to say that one of these brackets is this, and one of them is this. Now a minus b is clearly less than a plus b, since these are positive. Natural means positive integers, you should probably know that if you're taking this exam. So a plus b must be the 7, 6, 7, 3, and a minus b must be the 3. And this is just a simultaneous equation, right? If I take those away, these go away, and I get 2b equals 3670 divided by 2, put it back in for a, and you find a is 338, which is the answer. Now, what about what I was saying before, which is 200,019 could be 1 times 2019? Well, you can do that, but if you set up the simultaneous equation, you end up with a being bigger than 1,000, so that can't be the answer. It must be this configuration instead. Number 7, how many positive, I'm not sure what this question mark is about, I've just kind of ignored it. Integers exist such that that and that are 3-digit integers. So I need the first one to be between 1,000 inclusive and less than 1,000, 100 inclusive, less than 1,000 not inclusive, because this is a 3-digit number, but this isn't. So let's times everything by 3 and then take away 1. Now, that's not all the numbers that n could be, because it needs to be an integer, so I need to have n plus 1 be divided by 3 and give me an integer, which means n plus 1 needs to be in the 3 times table, which means n needs to be 1 less than something in a 3 times table. Now I know 300 is obviously in the 3 times table, so that means 299 is a number that I want, because then when I add 1 I get 300, which divides by 3 nicely, and then I can just work up in threes, right, all the way up until the highest one, which I'm hoping is not going to be important, because otherwise I'm going to have a lot of counting to do. Looking at the other one, just do the same kind of thing. Take away 1. That should probably be a strictly dance. That should have another dash in it, but it's not really going to make a difference, because as you can see, for both of these to be true, I need to be between 333 and 299. So yeah, this dash didn't really make a difference, but whatever. So yeah, all the numbers I can be are 299, 302, 305, 308, 311, all the way up until 333. In fact, the lowest one is 332, because again, remember, these are 1 less than multiples of 3, because n plus 1 has got to be 1. And I mean, I just wrote them out. You can do smarter things. I wrote them out and counted them and got 0, 1, 2, 12 multiples in total. Question number 8. Now, this is a bit of a weird one. If you're not really hot on functions, you're going to find it quite difficult. The first thing I'll say is that this axis should not really be the y-axis. It should be the f of x axis, or actually the j of x axis. Because what this means is the x-axis is the inputs. That's what you put in the function. And the y-axis is what the function actually gives you. So for example, looking at this, if I input 2, I get as my answer j of x 2. And that makes sense if you do the algebraic way. 2 is bigger than 0, so you put in 2, but you just get your number out. But you don't need to be concerned too much about this. You can just use the graph for this question, because apparently j of x is 0. Now, let's ignore the multiple j's here, and just boil this down to a much easier question. If j of x is 0, what is x? Like, if the function is 0, what x did you put into the function? And you can actually just use the graph for this, right? The function is being represented by the y-axis. So when is the function 0? Well, when you're on the x-axis. So you've got two options. Either x, your input was 0, or your input was minus 4. Both of those will give you an answer of 0, right? Because your y-axis, you're at 0 on the y-axis. So either of those will give you it. So if we go back to this for a second, j of some complicated thing is 0, means that complicated thing is either 0 or minus 4. So I can either say that j of x is 0 or j of x is minus 4. And now I can assess these, right? Again, I can do the same thing here. J of something is 0, well, that's either 0 or minus 4. So that means this something, j of x, is either 0 or minus 4. And here, this is just the same question again, right? When does j of x equal 0? Well, when x is 0 or minus 4. So those are the two answers there. But here, when is j of x minus 4? Well, again, look at the y-axis. When do we get to minus 4? Well, it's way over here somewhere. And we maybe have to do a bit of algebra here. If I input, I want to input something and get minus 8. Now, it looks clear that I'm going to have to input something quite negative. So, and then we can look up here and we can think, well, actually, if I input I want to get minus 4. I misspoke because I know what the answer is. If I input minus 8, 4 plus minus 8 is minus 4, and so I get it. So x needs to be minus 8 here. And here, doing the same thing, looking at this here, I need the function itself to be minus 4. Well, we already just discussed that one. That means that the input needs to be minus 8, but this time the input is j of x itself, so that means j of x needs to be minus 8. And when is the function minus 8? Well, that's clearly off the graph, but we've done this before. I just need this thing to be minus 8. So I think I need x to be minus 12, because 4 minus 12 is minus 8. So that's going to give me my x is minus 12, and there are 1, 2, 3, 4 solutions, which is an answer of 0, 0, 4. Quite a tough question if you're not too hot on functions. Okay, what's the smallest three-digit number k, which can be written as that? Now, a and b are both one-digit positive integers, it should say. Now, I have to admit, when I did this, it took me about 14 seconds, because what I figured was, well, if a and b are too small, like 1 and 2 or 2 and 3, this isn't going to reach 100. Like, I need it to reach a three-digit number. So let's go in the middle somewhere. Let's choose 6, and then let's just choose 2. 6 squared is 36. That gets me pretty high. 2 to the 6 happens to be 64, and then you just bang on get 100. And of course, because 100 is the smallest three-digit number that exists, that's the smallest three-digit number that it's possible to make. I don't need to test anything else. And so that question took me, just by luck, took me basically no time at all. If you're given something as restrictive as one-digit positive integers, it's possible just to sit here and try stuff. And maybe you won't even be trying for very long, because you'll get it straight away. Number 10, this one we just have to take a deep breath and just do it. So let's do this multiplied by this first, because hopefully with all the symmetry something nice might happen. So when you're multiplying things underneath the surds, you can just put them both underneath a single surd. You know, basically root a times root b is root ab, so I can just put them underneath a single surd. And now I'm going to expand brackets. 13 times 13 is 169. Now 13 times minus this is going to cancel with 13 times plus this, so I don't need to write that. And then I'm going to have minus this times this, and again I can put the thing underneath the same root because it's a rooty thing times a rooty thing. But then this is critical. You need to look at this and think, well, this is this thing times itself square rooted. So this thing is being squared because it's timesing itself, but then being square rooted, so I can just cancel those out, and I can just be left with that thing there. And then of course I can simplify this, and this is amazing because you notice how much symmetry it has with that, and now I can times by this thing as well. And I'll do that on the next page. Same kind of logic here, put them underneath a single surd. In fact, I don't even need to do that. This times this is 141 squared. This times this will cancel with this times this, and then this times this is just minus 281 because the roots cancel. There are probably intelligent ways to do this. I just squared 141 to get this, and then took away, and then breathed a very deep sigh of relief because I know 14 squared is 196, which means this must just be 140. Good. Question 11. So this is a bit confusing, this question. AC is the same length as A to N. Now you could put dashes here, but I think that gets really confusing. So I'm actually just going to really say this length is X and so is that length, just so that I know exactly what I'm talking about. And likewise BM, which is this length, is equal to CB, so that length is equal to that one. And that's, I think, more clear to me than putting dashes. Now this length, this angle here I could call alpha, and this angle here I could call beta. Now notice I'm being asked for ACB, ACB. So if I call this angle beta, I'm essentially looking for what alpha plus beta plus 43 is. Now if I call this angle alpha, this one here is 43 plus alpha, which makes this angle down here, based on this isosceles triangle, ANC, alpha plus 43 as well. And now if I call this one beta, same idea, this is an isosceles triangle, which means 43 plus beta is also over here. And now looking at this middle triangle, I can say 43 plus beta plus 43 plus alpha must equal 180, because that's how many degrees in a triangle. And if I simplify that up, I get alpha plus beta is 51. But remember, what I'm originally looking for is alpha plus beta plus 43. So all I need to do is add 43 to 51, and I get my answer of 94. Put a 0 in front because it wants the three-digit code, 094. Excellent. Question 12. So with this one, this is one of those classic questions that you just need to get rid of all the roots. You need to replace those with fractional powers, and you just need to see how it goes. You also need to change all the bases to their most basic base that you can. In fact, I'm thinking about whether I did need to do that now. Anyway, that's what I've said, so I'll do it. So this cube root is actually to the power of the third. 16 is 2 to the 4. We've already seen that one in this test today so far. Root x is 2 to the half, and then of course these things are multiplying, so you add the powers. 4 plus a half is 4.5, which is 9 over 2, and then you multiply these, of course, because there's brackets. That makes 9 over 6, which simplifies to 3 over 2. So that's that one. B, this is the one I was thinking about. So again, I've made the root a half, and then I've made 9 3 squared, and cube root of 9 to the power of a third, and then I've changed this 9 again. That's 3 squared, so that gets multiplied by that to make 2 thirds. Add it to 2 to make 8 thirds, and then multiply by this half to make 8 sixths. I actually don't think I needed to do that anymore. I think I could have just kept the 9s as they were. But regardless, you get this. Next one, this one's actually a little bit easier. This is 2 to the power of a fifth because of this third. Times that by 2 to get 2 fifths, times it by 2 again to get 4 fifths. And then it's asking me to do a squared plus b cubed plus c to the 5. So that's going to be this thing squared. And again, 3 over 2 times 2 is just 3, so that's nice, that's just 8. This thing cubed, and again, this works out quite nicely because 8 times 3 is 24, divided by 6 is 4, so that's 81. And again, I think I could have just left these as 9s, but whatever. And then c to the power 5, well, that to the power 5 is really nice. The 5s cancel when you multiply these to get 2 to the power 4, which is 16. Add those together to get 105. Quite a nice question. The real numbers a and b, such that someone said on this. Now, this is actually just basically an A-level question, I think. If you're doing A-level maths, I don't think it's even further maths, I think it's just A-level maths, you should kind of recognize the substitution you need to do here. If you let y equal 3 to the power x, 3 to the 2x can be written as 3 to the x squared, because we multiply these for 2x, which is just y squared. And likewise, 3 to the x plus 1, that can be written as 3 times 3x, because there's a 1 here, and then you add these together for x plus 1. And that's just 3 times y, so 3y. And just put that in there, so we get y squared minus 10 times 3y. Plus 81 is 0, that makes minus 30y. Look for things that multiply to make 81 and add to make, well, they both have to be negative, right? Because you've got a negative here and a positive here. So I think it's going to be, well, I worked out it was minus 27 minus 3. So y is 27 or y is 3. But again, y isn't the thing you care about. X is the thing you care about. So replace the y back again with 3 to the power x to get this. 3 to the 3 is 27, or 3 to the 1 is 3. So those are our two answers. A is bigger than B, so this must be A and this must be B. Just put them in here. 20 times 3 squared plus 18 times 1 squared, and you get your answer of 198. Good. Question 14. So I'm not going to go into detail about this question. I'm going to put a video in the description that explains this in depth. But in case you haven't seen this before, if you ever have a number in its prime factor decomposition, so this is just an example of what this number could be, because it's the product of 3 distinct primes. To find how many factors that number has, you simply take the powers of each prime, add 1 to them, and multiply. So the powers right now are 1, 1, and 1. So I add 1 to all of these to get 2, 2, and 2, and then I multiply to get 8 total factors. And you can check this if you want. 2 times 3 is 6, times 5 is 30. You'll find 30 has 8 factors if you do this. Again, I'm not going to go into detail exactly why that is. I'll put a video in the description that I made explaining that in full. But essentially what I can say here is that, well, if n is just 3 primes multiplied together, and it's useful to note here that the 2, 3, and 5 had absolutely no bearing on this. If that had been 11, 13, and 17, everything would have been exactly the same. So any 3 primes, that means n to the power 5 is just these 3 primes raised to the power 5, which then distributes out to these to make P5, Q5, R5, and then you just use this rule again, right? You add 1 to all of the powers to make 666, and then you multiply the 6's together to find you have 216 total factors. Again, I'll put a video in the description to explain exactly where this rule comes from, but it is nice to know, and it allows you to do this question very quickly if you just knew that rule. Question 15. So 5 things are in a field, and they're not in no 3 of them are in a straight line, so they look a bit like this maybe, where no 3 of them make a straight line. Each one of them knows the different distance between them and all the others, and they kind of just say them out. So if this one is number A, all of these distances to all of the other ones added up make 17. And then if this is B, they're also going to do that. They're going to add this distance to this distance, this distance, this distance, and that's going to be 43. If you imagine I just bothered to put B1, B2, and so on down there. But the thing is, we've measured this distance twice now, right? This one was measured when A called it out, and then when B called it out. So if we extend this, I'm not going to bother writing all down, but if we extend this after all of them have said their thing and add them all up, essentially all we're going to have is 2 copies of all of these different distances, right? Right now we only have 2 copies of this one, but after we've done this person as well, we'll have 2 copies of that, and then when we've done this one, we'll have 2 copies of that, and likewise for this distance, because we'll have that person at that point. So we're going to have 2 copies of every line connecting every point, and that's just going to be 17 plus 43 plus and so on. So I'm just saying, if you add up all of these, you just get 2 copies of every single line, and then of course you get the sum of all of these things, which is this. So that means 258 is 2 copies of every line, so divide by 2, and you find every line added up is going to be 129. Okay, number 16. Cool, so you can do this in other ways, but what I noticed first is if you just take this one and take away this one, you get y minus minus x, so y plus x, is equal to 208 minus 880, which is 28. And that's quite useful to me because I can rearrange that, and then I can just take one of the equations, factorize it, and then just stick a y minus 1 into here. Now y minus 1 is what, 27 minus x? And I just stick that in, and now I have something I can solve for x. Now there are tons of ways to do that. Essentially all you needed to do was make these two simultaneous equations into an equation with just one variable. But that's one way of doing it. There are tons of other ways. Expand that out and rearrange it. I faffed around here for a long time before finally working out that 15 times 12 is 180. So the answer is 15 and 12. And I've said that's x1 and x2 because those are the two x solutions. Now I need to say what y1 and y2 are. Well, if x1 is 15, then that makes y1 13. And if x2 is 12, that makes y1 16, y2 16. And notice it doesn't matter which order I wrote those two things in because this is a symmetrical thing they're going to ask me to do. So I've got x1, which is 15, plus 10 lots of 13, plus 12, plus 10 lots of 16. And that should be fairly straightforward for me to do. And I get my answer. Number 17, so draw a picture, then got a triangle ABC, BAC is 120, length of AB is 123, midpoint M makes, the midpoint of B and C makes a line segment that's perpendicular to AB, so there's a 90-degree angle here, which means I can split that 120 into 30 degrees and 90 degrees. And of course, these two distances are the same because M is the midpoint. And they're asking me for AC. Now, this question is hard. Really impressive if you got this in time, because it takes a lot of imagination. I don't know whether there's another way to do it, but the way that I did it was I drew an extra thing in here. Now I drew this out. I just extended this line out and then extended this line out and said that angle there is 90. Just by choice, right? Like you can appreciate I can move this line in any direction I want. I'm going to put it in the place such that I make a 90-degree angle there. Now I know because this is a straight line that this angle is 60, and therefore because this is a triangle that this angle down here is 30. And now there are probably lots of different things you could do from here, but what I said is that if you look at this triangle down here, ABM, that triangle is similar to this triangle, right? I know that because these angles are both 90, so these lines are both parallel to each other. So that's got to be similar shapes. Now, how much bigger is the red shape to the blue shape? Well, because M is the midpoint, and this length is exactly a half of the whole thing, the red shape is 2 times the blue shape, right? Because this side is being doubled in length to get all the way over there, which means this 123 also needs to double in length to get all the way over there. So this side here, between A and this point I've made up, is also 123. And now we can look at this triangle, because it's a right-angled triangle with angle 30, 123 over there, and I want this side. So I think this is opposite over hypotenuse, cos of 30. Oh my gosh, what have I done? It should be sine of 30, shouldn't it? Sorry, that's my bad. This should say sine of 30, and of course sine of 30 is a half. It's just complete nonsense. Sine of 30 should be here because it's opposite over hypotenuse. Sine of 30 is of course a half, and that makes x 246. That was just a mistype on my part. That should be sine. Okay, good. Question number 18. Apologies for messing that up. An integer is said to be chunky. So this is a number theory question. It's defining something where this is nonsense, by the way. I don't think. Well, I don't know that. I don't think this has any actual standing in proper maths. I think they're just making this up. A number is chunky if for each of its digits the whole number is divisible by that digit. So 963 is divisible by 9, 6, and 3. So it's chunky. How many are there between 13 and 113? Now, I had no idea how to do this question, so I just started listing them out. and looking at them. Now, I know all of the digits are obviously divisible by 1, because everything's divisible by 1. Now, I know 13 is prime, so that's not divisible by 3. 14 isn't divisible by 4. 15 is divisible by 5. 16 not by 6. 17 not by 7. 18 not by 8. And 19 not by 9. So the only one that is in this list is 15. So that's just one number. Now, I still don't really have any understanding of what's going on, so I'll just do it again for the next 10. Now, all of these numbers, if they're chunky, need to be divisible by 2, but of course only even numbers are divisible by 2, so I can cross out all the odds straight away. They're not going to work. 22 is divisible by 2 and 2, 24 is divisible by 4, 26 isn't divisible by 6, and 28 isn't divisible by 8, so I only have 22 and 24 from this bit. Still don't know what's going on, but I'm actually understanding that it's not really taking me that long to do this, so if I do just have to list them all out, I'm not completely against that. These need to be divisible by 3, so only the numbers in the 3 times table have any chance of working. So I can cross out all of them except 33, 36, and 39. 33 is divisible by 3 and 3, 36 is divisible by 6, 39 isn't divisible by 9. And now I have this kind of hope, because what I notice is that because the first number is increasing, there's less and less numbers that even stand a chance, right? Only numbers in the 4 times table are going to work here. So I can cross out anything that's not in the 4 times table, which is most of them, and then 44 will work, spotting a pattern here, and 48 will not work. Sorry, it will work, because 48 divided by 8 is, of course, 6. Yeah, 6. Okay, so 48 does work as well. Now, 50s, anything in the 50s will have to be divisible by 5, but the only thing in the 50s divisible by 5 is 55. So 55 is the only thing that has any chance of working, because it's the only thing that ends in a 5, and I'm not allowed things that have a 0 digit, so I can't use 50 or 60. You'll have noticed I've skipped the 0 digit every time. In the 60s, I'm only going to need things in the 6 times table, but the only thing in the 6 times table in the 60s is 60, which I'm not allowed, and 66, so 66 will be anything. Same for the 70s, same for the 80s, right? Those are the only things in that set of 10 divisible by 6, 7, or 8. So those are the only things that will work. In the 90s, the only thing will be 99, because it's just 90, which I'm not allowed, or 99. So those will be the only ones. And then in the 100 and somethings, everything from 100 to 110 has a 0 in it, so none of them are relevant. So I then just need to look at these 3. And this works because everything is divisible by 1. This works because it's even, so the 2 is fine. This doesn't work because that's not divisible by 3, which I just had to use a bus stop quickly to find out. And now I just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I think. No, apparently I miscounted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, 0, 14. Yeah, weird question. Number 19, another shape question, so draw it. Now, I have to admit, I've probably done this question in not the way that will be very helpful to you if you've... Well, actually, no, I disagree with that. I think I've done it in a really helpful way if you didn't know how to do this question. I haven't done it in the cleanest or fastest way, but I think it is very helpful. Now, this is just me setting up the problem. This is just what the problem talks about. There's 2 lines going across like this, and this is the point P and Q, and you're interested in the area of the triangle APQ. So that's just me drawing what information is in the question. It's asking for the area of the triangle APQ. Now, as soon as I see a problem like this, I immediately know that I can solve it, because what I can do is I can just do what's called coordinate geometry. In my head, I call it coordinate geometrying it, mate. That's what I say in my head. So all I'm going to do is slap some axis down over the top of this and pretend this is just lines and stuff. So this line here clearly has a y-intercept of 0. You've got to imagine this is the x-axis and y-axis here. This has a y-intercept of 0, and it rises 105 for running across 105. So this is just the line y equals x in this system that I've made up. This line has a y-intercept of 105, because this is 105 high, because that's the side of the box. And its gradient is negative, because it's going this way, and this distance is half of this distance. So it's y equals minus a half x plus 105. And likewise for this one, this is a quarter of this distance. So that line is y equals minus a quarter x plus 105. Now, what am I doing here? Well, I'm just going to find the coordinates of these 2 points by setting these 2 lines equal to each other and these 2 lines equal to each other. That gives me the coordinates of these 2 points. So for P, set this line equal to this line. This is very easy to do. You just add this to both sides, times by 2 divided by 3, and you get x is 70. Now, of course, this is the line y equals x, so any x coordinate is going to be equal to the y coordinate. So this is the point 70, 70. Same thing over here. Ends up being very similar, and you get the point 84, 84. Now, where am I going with this? Well, what I'm going to do, after I clear away all of the fluff that I no longer need, which is basically everything, is I'm going to look at this box here. Because this box has a height from 70, because that's the y coordinate of there, to 105. So its height is 35. Its width is obviously 84, because it goes across to x is 84. So the area of this red box is 35 times 84. And all I have to do to work out APQ is take away this triangle, and this triangle from that. Now this is a bit annoying because these numbers are a bit big, but I can do grid multiplication, so I'm okay. This triangle here is a half times 35 times 70. So I'm going to take that, whatever I get from that, away, which is this. This triangle at the top is width 84, height 105 minus 84, which I think is 21, times a half because it's a triangle. Take that away, which is that, so that's that. And then this little triangle down here is width 14 from 70 to 84, height 14, so it's a half times 14 times 14, which is that. Take them all away and you get 735. Again, that's probably not how anyone would have attempted that question normally, but it is a really good instructional moment whereby bear this tactic in mind. If you ever see a shape question, bear the tactic in mind that you could just put some axes over the top of it and just answer this using lines and algebra as if it was on a XY axis. It's really efficient work. I don't know whether it's efficient, but it's really effective for sure. It will work. It might just take some time, but it does work, and that's how I did 19. 20, Senior Kangaroo always seems to end with these crossword puzzles. 101, I did some bus stop division to find out is 11 times 91, and then 91, I just about know at this point, is actually 13 times 7. Now, 1 across is a composite factor of 101, so it's not any of these because these are prime factors. It's what happens when you multiply some of these together. So 11 times 13 is 142, but 1 across is a 2-digit number, so that's not right. 11 times 7 is 77, and 13 times 7 is 91, as I said before. So it's actually just got to be one of these two numbers, right? Because it's a 2-digit number. So that's fairly limiting already, which is good. So sure. 3 across, this 3-digit number, is not a palindrome. Now, a palindrome is a number that reads the same backwards as forwards, like 252. So that's not very helpful. I don't want to list all the non-palindromic numbers. That's far too much. But it is useful to know that this number can't be the same as this number. Because if it's 3 digits, like 373 or 424, essentially what this is saying is that this number just can't be the same as that. Okay, what about this? PQ, 5 across. Now that's a 2-digit number. PQ cubed, where P and Q are prime. So these are the primes, and I need to use 2 different ones to make PQ cubed. So if I use P as 2 and Q as 3, I get 2 times 3 cubed, which is 54. If I use the other way around, P as 3, Q as 2, I get 3 times 2 cubed, which is 8, so 24. And I can keep doing this, and I'll try and use the smallest primes because it's only a 2-digit number. And I quickly work out that using 2 in the Q is good, because using 2 in the Q makes it only 8. And I can put lots of other primes next to it. Now, I can't go up to 13. Clearly 13 times 8 would be too big if 11 times 8 is already 88. And even if I try and make Q even slightly bigger than 2, I've done it once here, but if I go to the next prime on the other one, I can't use 3 and 3 because they're different. I end up too big. So actually, these are the only ones I can use. This, and this. And I'm going to put those in a table. And those are all the ones that had acceptable answers. This should definitely say 88. I don't know what I was doing there, but that should 100% say 88. 2 cubed is 8 times 11 is 88. It's not going to make a difference, spoilers, but that doesn't make a difference, but that should say 88. Anyway, let's move on and stop looking at it. 1 down is 1 more than a prime and 1 less than a prime. So we're looking at numbers like 12, which is 1 more than 11, which is prime, but also 1 less than 13, which is also prime. Now the problem is, it seems like, oh, there's so many 2-digit numbers that could do that, except there aren't, because this number has its first digit shared with this number, and the only digits there are 7 and 9. So I only need to look at numbers in the 70s and numbers in the 80s. And in the 70s, the only one I can find is 72, because 71 and 73 both seem prime. 74 won't work, because I know 75 isn't. 77 won't work, 76 won't work, because I know 77 isn't. and 78 won't work because I know 77 isn't on its other side. So 72 is the only thing that's going to work here. Notice I only need to look for even numbers because if I have an odd number, the numbers either side are even, which aren't prime. In the 90s, if I look for 92, say, 91 isn't prime. I know that because I looked at it earlier. It's 7 times 13 or whatever. I don't know, can't remember. So 92 doesn't work. 94 doesn't because 95 is definitely not prime. 96 doesn't because 95 again isn't prime. But 98 couldn't because 99 isn't prime. And so actually none of the 90s will work at all. 98 doesn't because 99 is not prime because it's 9 times 11. So actually this is the only thing that will do that. So I can put 72 in there, and of course that locks this to be a 77. So that's nice. I've made some progress immediately. I know this so far, and I can look at this. Now, it would take a true... So this is 2 down. So this is a 3-digit number that's a multiple of 9. Now, the only saving grace here is I know it starts in a 7, but still, that's quite a lot of numbers, and it will take a true madman to bother writing down all of the multiples of 9 that are 3 digits long and start with a 7. So there they are. That's all the multiples of 9 that are 3 digits long and start with a 7. Now, I know I'm not allowed to use zeros, so I can't use this or that. None of the answers can have 0 in them. So that's the multiples of 9 that I'm now looking at. And now we'll look at the last bit, p cubed q, using the same p and q. So this is actually why I wrote this little table. It's because now I can extend it. And 4 down has to use the same p and q. But this time, notice they've just swapped where the cubed is. And so this is the same kind of thing. This one, if I use p as the cube and then 2, this is just going to make the opposite case for this one, right? Because essentially I'm just using the symmetry. Now all of these 3 will be too big, because if I try and cube 5, I'm already too big. Cubing 7 and cubing 11, obviously, way too big. So all of those are way too big, which is why I'm not too stressed about making a mistake here. And this one is just going to swap over just like this one did. So this is really nice because it means that 5 across is either 24 or 54, and 4 down is the other one. It's 54 or 24, it's just the other thing. So I know this digit is a 4, so that's good. And how do I make progress here? Well, remember, 3 across, not a palindrome, which I said meant that this number was not a 2, which means this number can't be the 24, this must be the 54, which means this is the 24. And now if we look at 2 down, our multiples of 9, which one ends in a 2? Well, it's just this one, so a 9 must go there. And now 3 across is the answer, it's 295. Hope you enjoyed that, and thanks for sticking with me.